Hello, my name is Robert LeGros, and we'll be discussing basic digital electronics. The first thing we have to understand when talking about basic digital electronics is how they understand information. This is very simply done with binary code. Binary code is very similar to the base 10 counting system that we're all familiar with. However, instead of 10 digits, 0 through 9, it only has 2 digits, 0 through 1. So therefore, at number 3, instead of going to an actual digit that represents what would be 2 in base 10, we go to 1, 0, which would be their next place value. So therefore, as you're counting in binary, you start with 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, and so on. Now that we have a basic understanding of binary, which is the basic language that all digital electronics understand, we're going to discuss gates, which is how digital electronics understand this language. From here on out, I'm going to be referring to zeros as negative and ones as positive. What we have here is a listing of all of the basic gates that are used in digital electronics. The first gate we're going to be talking about specifically is the AND gate. Now the AND gate looks like this, and what we have here are 2 inputs and 1 output. Now you can have any number of inputs, however only 1 output of any gate at one given time. Now we're going to be just focusing on all the gates with just 2 inputs for now. However, the formula for each of them stands the same. On an AND gate, it is named so because you will only get a positive output or 1 output if all of the inputs are positive. Therefore, when you're looking at a readout of all the possible inputs and their outputs, you will have a 0 all the way across the board until you get to the final one, which is a positive or 1 on all of the inputs, like this. Next, we have the OR gate. Now, an OR gate is very similar to an AND gate. However, it will give you a positive output as long as there's at least 1 positive input. For example, if you have all negative inputs on a 15 input OR gate and only 1 of them is a positive, then you will get a... The next basic gate we're going to be talking about is the NOT gate. The NOT gate is often represented with only 1 input because it very simply just flips whatever input it has to the opposite. So if you have a positive input on a NOT gate, you'll get a negative output. Or vice versa, if you have a 0 or negative input, you will get a positive output, as demonstrated by this image. Okay, now we're going to talk about combinations of gates. We have the NOT gate, and if you go ahead and put that on the front end, or the output of an OR or AND gate, you end up with a NAND gate or NOR gate, which very simply has an output that is exactly the same as either an AND gate or OR gate. However, instead, you get the exact opposite output. For example, an NOR gate will have a negative output if there's any positive input put into it, and only if you have 2 negative inputs will it have a positive output. And the same goes for the AND gate. The output will look exactly the same as an AND gate, however, exactly the opposite. Now the next gate we're going to be talking about is the exclusive OR gate. Now the exclusive OR gate is very similar to the OR gate. However, the outputs are exactly the same except for the last one where you have all positives as the input. The exclusive OR gate will only get a positive output if you do not have all of the inputs granting a positive. For example, if you have a 0, 0 on the input, you will get a 0 output. However, if you have a positive, positive or a 1, 1 input, you will also get a 0. Any other combination of positives in will give you a positive out, just like the regular OR gate. Now the last one we're going to be talking about is the exclusive NOR gate, often called the universal gate, but that's for a different reason that we're not going to get into now. The exclusive NOR gate is very similar to the exclusive OR gate, except just like with all the other NOT gates, or NOR gate, the NAND gate and NOR gate, the output is exactly opposite of its predecessor. So the exclusive NOR gate has the exact same output as the exclusive OR gate, just the exact opposite. Therefore, it will only give a positive output if it either has both zeros as the input or both positives as the input. Any other combination of any positive in will render a 0 or negative output. And that concludes this segment on basic digital electronics. After reviewing all this information, you should have a basic understanding of how all digital electronics do what they do. These basic inputs equal a basic output, and this is how we program them to do all the various things that they do. Thank you very much. Have a great day.